Hello everyone, this is Brian James from Rhino3D.com, and in this Rhino video tutorial we'll be taking the model out of the computer and making it on a regular printer using regular paper. We're also going to be using a free plugin that allows you to make several hundred polyhedra, and it's available on the McNeil Wiki. This is the web address for it. So go to this site, read the instructions for installation, and you can get a brief synopsis of what it does. And you can also email the developer, Dale Fugé, and say, thanks Dale for making this plugin. It's really cool, and you'll see what you can do with it right now. So after you install that plugin, you can run a command called polyhedron. And polyhedron gives you a drop-down list of all these different sections of polyhedra. And I'm going to enter the platonic solid section and then make a solid dodecahedron. I'll place the center at 0, and for the edge length, each one of the sides of each face, that edge will be 1. So I'm working in small objects inches, so this is going to mean 1 inch for the edge length. And then I'll type ZEA to zoom extents all viewports. Didn't make a lot of difference there, but good practice. And then I'll move this object with the move command from the mid snap on the bottom edge to 0. And then in the front view, I'll use the rotate command to rotate from 0, use an end snap, and then hold down shift before left clicking in order to keep it straight. And now it's flat on top of the top construction plane. And now I can use ZEA to zoom extents all viewports. And you can see the polyhedron that is created. And this dodecahedron has 12 sides, and each side is a pentagon. Now if you wanted to make this out of paper, you'd need to flatten it into a pattern that you could cut out of that sheet of paper and then tape or glue together into a form in the real world that looked like this. And there's a cool command in Rhino called unroll srf. Unroll srf will do just that, and you'll have some options in the command line for whether or not to explode all the faces in the poly surface or label them with dot objects. These are the settings I'm going to use: no, no, and no. So I'm going to select the poly surface and then press enter, and you can see what happens. Let me maximize my perspective view here. The dodecahedron is unwrapped or unrolled into this arrangement. And right now, if we wanted to add additional planar surfaces that represented a tab structure in order to glue or tape the model together, it'd be a little hard to figure out where we want to add those tabs. So we're going to make this, I'll leave this one over here just for comparison. We're going to make this a little bit differently by first unjoining some of these edges. Now the concept of unjoining will tell the unroll surf command that we allow it to separate at these edges. So let me go back to my 4 views and run the command unjoin edge. And from the right view, I can just select all these edges in unison. And then I'll hold down the control key and left click to deselect one of the edges like that along the center. And then enter. And nothing appears to be different, but now if I run the unroll surf command with the exact same settings, I get this result, which is a lot easier to figure out in terms of adding tabs. I'll ZS to zoom selected. Now I don't need these lines. Personally, I don't think I want those lines. I'll just want the borders. So I'm going to turn off isocurve display so that I just see the edges of those surfaces. The next step will be to run the command called layout. And layout will let me pick how many details, and I just want one detail, and also let me input the dimensions, width and height. So this is my paper dimension going through the printer. And I'll say OK. And so we get this page tab at the bottom. So we still have perspective, top, front, and right, but now we have a new layout page, page 1. And this is really just a viewport, but it's called the detail when you're in layout space. And you can double left click it to make it an active viewport that you can pan around and control the model. So you can actually model in layout space if you wanted to. And I'm just going to rotate this, hold down Shift to keep that straight. And we can zoom in and out here. And I could print this, but what does it mean to actually print something this large on an 8.5 by 11 piece of paper? Will each one of these edges still be 1 inch? So there's something that you can do to scale the model so that 1 inch in model space equals 1 inch in layout space. And that's what I want to do here so that I know that I have the exact sized dodecahedron when I put it together out of paper. So double click, so you activate the detail, and then run the command detail. And up in the command line you'll see a bunch of options, and you can click scale, and I can say that the distance in layout space, currently 1 inch, will equal this distance in model space. And currently at this particular view it's this relationship, so I'll type 1 as well, so it'll be 1 to 1. And then I can run, I can just pan this over with Shift and right mouse button, so I center it. And then I can run the command detail again and click lock up in the command line. So now you can activate this detail, but you can't move the model or zoom in and out. All of that just moves this graphical display of the layout page. So we could still measure or add elements to this model like the tabs, but we now are assured that we have 1 inch for each of the edges. I'm going to go into the display panel here off to the right and uncheck isocurve display. And then I'll activate this view because I want to model some tabs that we could tape or glue together. And I'm going to use a planar surface, and I'm going to make a rectangular plane from 3 points. And then I'll use near object snap here for the first 2 points, and the third point is just going to be like that. And so this second planar surface, or this planar surface in addition rather, to the dodecahedron that's been unrolled, I need one of these tabs on each one of these edges. So I'll use the array polar command. And then for the center of the array, I'll use the intersection of 2 mid-snaps. And then I'll type 5 as the number, and 360 is correct. And then enter. And I can copy this from a mid-snap to a mid-snap. Let's see, do I have an edge somewhere around here that matches up with that? I'll move this now from this mid-snap to this mid-snap, like that. So I really should have copied it from that midpoint to that midpoint. But now I can take this and I can run array polar again, also using the intersection of 2 mid-snaps to find the center. And then I'll just enter through the same settings. Now these exterior edges will also need tabs so that the top and bottom can be joined together. So you can use the mirror command to mirror from a mid-snap to an end. Nope, that's not right. Try again, from mid to end, like that. There we go. And now I can take that new tab and array polar between 2 intersecting mid-snaps again. And if you need one on the other side, you can do that again. Like that. Okay, and now the detail is locked. So we can immediately just go into the print command, and you can pick your printer, and you also know that your scale is set to 1:1, so have scale set to 1:1 since you already ran the detail command and scaled. And I'm going to use vector output here, and I think that's about it. Yep, I think that's all we need. So now I'll print this, and I'll be back in a second. Okay, so this is the printout, and I've got the ruler down there so you can see the 1-inch length for each edge of each side of the dodecahedron. And we've got the tabs too, so we don't want to cut off the tabs. We want to follow this edge all around, and use scissors or a mat knife and a ruler. Cut away from yourself and be careful. Take your time. I'll be back when I've got this together and show you the result. Alright, so this is what it looks like after you remove all the paper, and now you can use tape or a glue stick. Double-sided tape would be the easiest type of tape, I think, and a glue stick should work as well, and I'll use that if I can't find my double-sided tape. Be back in a second. Alright, so here is the assembled dodecahedron, and you can see those tabs around the middle that I used to connect the top and bottom shells together. And I'm sure there are other tab structures that would work for this, but please experiment. Try and make some other shapes from the Polyhedron plugin, and email any pictures of your models that you put together in the real world. Love to see them. You can email tech@mcneil.com. Thanks for watching.